Hello and welcome back to another look at the capabilities of MaxIm DL6. Today we're going to be taking a look at color combining images, which MaxIm DL does once again really well. MaxIm DL allows not only for combining of red, green, and blue images, but also allows people to stack the reds, the greens, and the blues prior to their being combined into a color image. So perhaps you have 6 each of reds and greens and blues. It will do that as well, and it will also calibrate the images on the fly. It's a pretty magnificent application in that regard. So let's take a look at simple red, green, blue color combinations, and then we'll get into something even more complicated in our next video. You might remember from our prior look at the images that we were using in prior videos here that we've been looking at images of the Pelican Nebula, and I happen to have a series of images in hydrogen alpha, in oxygen 3, and in sulfur 2, which is kind of cool. Looks like I have 6 each of sulfur and oxygen, and I have a ton, over 18 in hydrogen alpha. So let's color combine these images, and let's do it the MaxIm DL way. The very first thing we want to do is make sure that MaxIm DL is set up properly by going to the Process and Set Calibration menu screen and make sure that we've got all the correct biases, darks, and flats. This time it needs the flats for everything. Well, not everything. It needs it for hydrogen alpha, oxygen, and sulfur at a minimum. And this one also contains blues, reds, and V greens. But we're okay with what we have there. At this point, we can look at the color menu, and it's like nothing there is selectable. And you may think to yourself, well, why not? Well, it's because we want to go back to the process menu and choose stack. Kind of a subtle thing there, but that's okay. So let's take a look at the stack menu one more time. Here, we definitely want auto calibrate to be checked. I'm going to turn off by object because we're only looking at one object here. Most importantly, we want the classify by filter checkbox selected, and we need to click on the filter button. We need to take a look at what's going on inside there. This is actually really important, and most people get into trouble here more than any other place, because it is here that we tell MaxIm DL what your fits headers say for each of your filters. So for the red filter today, I know that MaxIm DL is going to be looking for HA for hydrogen alpha. For the green filter, I know it's going to be looking for OIII, or oxygen 3. And for blue, it's going to be looking for S2. If it doesn't find those exact terms in there, in your fits header, then it won't find the images and it won't put them in the proper color group. So for example, if your reds are all named red from the cat next door, you got to put it in there exactly like that, or it's not going to work. And yes, it is case sensitive, so be completely mindful of that. If you're not worried about things like the luminous or the sign magenta and yellow at this point, just leave them as is. But do change what you've got. Maybe you've got RGB, maybe it's VBR. I don't know. Whatever you're using here, you've got to change it. There we go. So now it's ready. We can add files to this, and I'm going to add 6 each of these colors. Doesn't matter how you select them at all, as long as you're grabbing the files that you want converted into a color image. So 1, 2, 3, 4, 5, 6. We got 6 H alphas, 6 O3s, and 6 Pelican S2s. And we'll say open. Now watch what it does. It creates a group, and it creates a red, green, and blue subgroup. And if we check, the S2s are indeed all in the blue. The greens are all in, the O2s are all greens. O3s are all greens, and the H alphas are all reds, which is exactly correct. So that's nice. We know it's going to auto-calibrate each image. We're going to ignore the quality section here because we happen to know that the quality of the images is fine. We want to make sure it says auto star matching in the alignment, because we know that between each image set the telescope is tracked a little bit. Looking at the color screen now, this is actually all new, so let's talk about it a little here. The color screen allows you to weight the amount of color or the amount of luminance and intensity of each color that each image set gives to the final image. And the reason for that is because you may have filters that do not allow equal quantities of light through them. So for example, if I know that my blue filter is a particularly dark blue filter and it takes twice as much time for it to gather the same amount of light as the green or red filters, I can change this from a 1, which stands for 100%, and I can change it to a 2. You can also use decimal values. Maybe it's only a 1.5. Maybe the green filter allows way too much light through it and you want to take it down a little bit. You can put it down to 0.6. You can do that. All of these are selectable and adjustable. Just make sure you write down what your filters happen to be. Sometimes you can contact the filter manufacturer and they'll tell you, which is really nice. Otherwise, you're going to have to do this by experiment. And probably one of the best ways to do this is by looking at stars of standard color that are on the well-known location on the HR diagram, and then adjust them so that they look appropriate to the human eye. Another way to do this is by looking at hydrogen alpha emission lines, or emission nebulae, and it has that distinctive reddish pink color to it. You can edit your images on changing the red, green, and blue balance here so that it gets as close as possible to that. But for today, we're leaving it at 1, 1, and 1, and leave it at that. For the combined method for the individual stacks of red, greens, and blues, we are using the sum method, and in this case I'm going to change it to 16-bit integer because we probably want to save this out as a JPEG at the end because it's pretty, but certainly go ahead and select IEEE float if you wish and save it off as a file that you can open up in, say, Photoshop or something like that. At this point we're ready to go. You just say go and sit back and watch MaxIm DL perform its magic. And as you recall, it's opening each image, it's calibrating each image, it's stacking each image, and done. It has created a color image for us. And let's use a screen stretch and see what our color image looks like for this particular object. And we're going to get right in there and take a good look at what this object looks like. Not bad. Not bad. It may be a little bit overblown out in the red in the center. The blues may be just a bit too strong, but all in all, not a bad color image for the Pelican Nebula. So that's the process. That's the workflow, if you will. And at this point, you can save this as either a TIFF image or as a FITS image, both of which are editable. The TIFF would be in Photoshop, and the FITS image would be in MaxIm DL. Pretty neat, huh? Okay, thanks for watching.